few things you're going to need. You're going to need an ignition switch. This is a 7-pin. They do make a 5-pin and a 3-pin. I got the 7-pin due to wanting to add lights to it later. You don't have to go that crazy with a fuse. This is just, I can mount this clean, like hidden. It's kind of self-contained, and it was affordable. So, but you can use whatever fuse style that you want as long as it's high enough for the amperage that gets pulled from the starter. You need keys, of course, and a starter solenoid. This is a 2-terminal, 2-pin starter solenoid. They do make 2-terminal single pin. This one is not ground by the base like the single pin, so it will need a supplemented ground and then your signal or your start input from the ignition switch. You can get away with not using that, but you're going to have to run heavy gauge from your ignition switch all the way to your starter. This way you just have your powers between, and I'll show later on what I mean, but I just need a small 12 volt signal that'll let this do the load without having to put a heavy gauge wire all the way to it. You'll need wire. This is for the negative. I know it's brown. Most people think of the negative wire as being black, but I build harnesses for Audi and Volkswagen, and they always use brown. So I have a bunch of this just laying around. You can use whatever color you want as long as you understand what side of the circuit it's going on. You'll need a terminal, power wire, power terminal, and a battery. And this is that. But the switch that I got does not have it marked. So this is what I figured out with testing and continuity to see what everything does. But I'll get more into that as we build the circuit. All right, what we're going to start with is our power and our negative to the switch. It is a 7-pin, like I mentioned earlier. We do have to have a ground and a positive, or the switch won't be able to put voltage through any of the inputs. So we're going to start with that. I've already made a ground terminal for the backside of it. It's weathered and sealed, but I'm going to show you how you can make it yourself. You will need some wire strippers and crimpers. Any brand will work as long as it will strip wire very well and crimp. And you will need a spade connector. I'm using the heat shrink style because it will be on a go-kart. I don't want moisture getting into the back of the switch. It won't always be inside, and it's going to go through the mud. So all you do, if you don't know how to do this and want to see, this is a 14 gauge wire. On the tool, or if it'll focus, the stripper part has the numbers for the gauge wire. 14 is the second one. So I'm gonna go there, do it about I don't know, 1/8 of an inch, and strip it. I always twist clockwise just because it's out of habit, but whenever I put terminal ends on, I follow that same rotation. So whether you like to go clockwise or counterclockwise, doesn't matter as long as you do it with your terminal end. So this is a insulated, and on the tool you have bare and insulated. Make sure you use the insulated on an insulated terminal, because if you use the bare, it will puncture it, and then that kind of takes the insulation away. So all you do is put it on there, squeeze really hard, do a tug test, make sure it's not going to come undone. There you go. Now you have a insulated terminal in after you heat shrink it. I'm sure you could figure that out. All you do is heat up the end of it and it insulates. What I am going to do, since
I'm trying to show you switch operation and everything else. This wire will be the wire that's on the go-kart for the back of the switch, but there's also going to be like a little fuse panel there, and it will get extended. So what I'm going to do for testing purposes, I'm going to go ahead and strip this off and also show y'all like a simple way to make a fuse connection for whatever you want to use it for, because this will have 12 volts going through it. So what I'm going to do is this will go at the back of the switch, and then I'm going to put a 30 amp spade fuse in here, and I will make a jumper harness from the other end of it, and the fuse will just sit right in there. That way, if anything happens or if the switch fails, the wires don't start melting. It's a pretty good safety. So this is what I did. Very simple. This is going to go in the back of the switch because it's insulated, and it's actually going to be on the go-kart. The rest of this is just kind of for testing purposes and for learning, so you understand how the system works. All right, see how I told you that these are not really insulated, but they kind of are insulated? See how it flattens out and it crushes? Well, the one that I made for the other side of the fuse, which is still insulated, I went ahead and used the non-insulated side. And you see how I didn't flatten it out or crush it, but it's still good? That's what I mean by they are insulated, but they're not really insulated. So what we're going to do, like I said, it's a quick fuse holder. All right, well, the spades are a little loose, so all we're going to do is kind of push them together a little bit. This is a simple fuse circuit. You can even do this on your car if you had to in a pinch. You just press it in. Actually, that one's going to have to get spread out a little bit more, which is okay because this is just for testing, because it will have a different circuit when it's in the cart. Oh, come on. I don't get it though. But you kind of understand what I'm doing. I'm pretty much making a inline fuse without anything fancy. So this end's going to go to the battery. It's 30 amp fuse, and the other end will go to the back of the switch. All right, now we got our ground and our fused power side done. You're going to need a couple terminal ends, of course, because you don't want to sit there and just hold the wires to the battery. So all I'm going to do is loop them, pick one for negative side, which actually on most batteries, the negative side is going to be a little bit smaller than the positive side. And they do make two different style, like universal clamps like this. You're not going to be able to see it, but this one is a lot smaller than that one. And you'll see it when I put it on the battery. But just to let people know that you can't just buy one and use it on any other part of the battery, because you're either going to have to spread the negative one really, really wide to make it fit on the positive, or you're going to have to really crush a positive onto the negative. Just simple circuit. As I was saying, the terminals are a little bit different. I have the positive side here. This is the negative that I had made. And as you can see, it doesn't really slide on there. I could spread it apart, and you can tell that the bolt is not restricting it. I guess I could put a pry bar or screwdriver in there and twist it. But that does not want to go down because it is a different size. This is for the negative terminal. But you take the positive and it fits on there great. But you come over here to the negative side with the positive, and look how loose it is. I'm just telling you all that there is two different styles, because I work on cars all day, and it's good that people have tried to fix their terminals, but when you use the wrong terminal, all you're doing is creating another problem, or creating the exact same problem that you had before because you can't get the terminal in tight. That's why you see some people put like aluminum foil over the ends of their battery terminal or put screws in them. It's because they were using the wrong size terminal in. All right, like I said earlier, I had made I guess a pinout for the switch that I had, since it didn't have any, it has no markings on it at all. So my battery is connected. I got my positive over here, and I got my negative here. So what I'm gonna do, that's my ground on the back of the switch, the high one, and then that's my battery, or B plus is what some people call it. So what I'm gonna do is plug in my positive, and then up here is my negative. So now I'm gonna do my negative. And as you can see, they fit really tight, which is what I wanted, because like I said, these parts of the harness are going to be actually on the go-kart. Everything else, like the fuse and stuff, is just to show you all how these circuits work. And I mean, I'm an electrical specialist, so I kind of like playing with stuff too. So now what I'm going to do is build a very simple lighting circuit. Because if you look at what we have right here, B plus A1 has 3 positions. So what that means is everything's off at stop. It would be on there, it would be on there, and it'd be on there. So what I'm gonna do is show a circuit with the lights. I'll have a light that shows it, that is on for these 3 positions, and show you how the wiring works with that. And then I'm gonna have one light that only flashes when it's in the crank position, to, I guess, try to help you understand if you don't know, but also help you if you're trying to figure out how to wire a go-kart and you don't have a wiring harness for it. So, all right, turns out that I only have one light that actually works. The other one needs a bulb, but I don't have a bulb here in the garage for that. I'll have to get it from the shop tomorrow. We still have our ignition switch hooked up with the negative and positive. Still wired. We still have a fuse right here. This is the positive side of the light. This one didn't have a ground on it. So what I'm going to use is a banana leaf, or you can call them banana clips or whatever. They are just banana clips at the end of a wire. What I'm going to do is ground the light, because that is the housing is the ground on that. So you actually don't have to have a wire going to it. You just have to have it grounded to a metal frame, like whether it's your car, your motorcycle, or what. So I'm going to plug that into ground on the battery. Now, I could take this end, just plug it right here with my other lead, and touch the battery with it, and it'll come on. But we don't want that. We know the light works. I mean, that shows that it works, but you know how to just plug it into a battery and the light come on. What we want to do is make it come on with the positions of the switch. So we have the schematic or pinout that I made. I'm sure there's other pinouts like this everywhere. But for this 7-pin switch, this is what I came with. So if we're trying to look for putting lights, or maybe a radio on something, or like say you just want to pimp out your lawnmower or something, we're going to want to do the B plus A1, because in those 3 positions, from light to running to crank, it should have power. So what we're going to do, A1 is in the 2 to 3 o'clock position. If you're looking at analog clock, I know some people can't, but that's what those numbers mean. We're going to plug it in there, make sure it doesn't touch anything else. So now we should have a light in all 3 positions except for off. First position, second position, and even in the crank position, we have that light on. So if you're going to add anything like fog lights or headlights, brake lights, whatever. Yeah, I mean, this would even work on a little dirt bike, and you could turn it into a trail bike with some lights if you wanted to. I mean, it won't be legally a trail bike because it's part of the title, but you know what I mean. You could sneak around on the street with it if you wanted to, because at least you would have functioning lights. So now we're going to take it off for that, because now we want to see our crank signal. Crank signal on here is B plus S. So S is in the 9 o'clock position. Like I said, analog clock. So we take it, we flip it. Here's the 9 o'clock position. I'm going to make sure I don't touch anything else. It's not going to hurt anything if I do. I mean, it is fused. That's why I did the little generic fuse or do-it-yourself fuse or inside the system. But I don't want it to touch something else that gives us a false light, because I could literally just go to the bottom of B and it's going to light up, because I know I have B plus going to that battery positive. So we'll make sure we're on there, not touching anything else. The light's off. So now it's going to be, that's off, still off, off, and now it should light and goes away when I release the key. So this is what your starter solenoid is going to need to see. It's going to need to see this circuit. This circuit is going to tell, or is, like I said, one is a ground. It's going to be supplemented because it doesn't actually ground through the housing like the light grounds through, because the ground on the light housing is the negative side. So what we're going to have to do is add a ground, and then this circuit that we just did here is going to go to this side of the starter solenoid. So when your positive battery comes into here and it goes straight to the starter, that's what's going to make this jump, and that's going to crank the engine. And then as soon as it starts, you let go, it'll stay on. And that's where A1 comes in, because A1 has power for all 3 of these. And we know that it dies with that. So that would ground your magneto. And I know I'm getting a little ahead of myself, but it'll make sense throughout the video. All right, now we're going to make a very simple starting circuit with this switch and this solenoid. We already wired up the power and ground to the switch. It's connected to the battery right now, which isn't going to cause any issues because it's terminated in the switch. Now, if we started adding stuff, then it would send voltage out. But right now, it won't do anything because it has nothing that it needs to apply power to. So like I said, there is a 2-terminal 1-pin, but this is a 2-terminal 2-pin. So this is not grounded internally due to the base. This one has to have a supplemented ground right here, and then you have your start signal. So what I'm going to do right now is make a very basic circuit so you can understand. All right, so I have my power coming into the solenoid on the power side. We still need a ground. We need our signal from the switch to the solenoid, and then our load side, which would go to the starter, but I don't have the starter out here because it's still on the go-kart right now. So what I'm going to do is use some of these leads. I could use this, but It's kind of confusing, but it does make it really easy. So I'm going to use these so you can kind of see what it goes to. So I'm going to use the red one to go to the starter side of the switch. And if we look at the pinout that I made, the starter signal is in the 9 o'clock position. So it'll be right here. So now we have our signal. Now we need a ground. I'll go ahead and use the green one for ground. And it goes directly here. And I will hook this up to the battery. Now I know I don't have a load on this because it's not powering anything, but because this is like a relay or a solenoid, they similar like functions, but this takes a higher load than a relay can. But it will activate. You will still hear it activate. So it's not going to be on here. It's not going to be on here, but it will activate there. Can you hear it? And that's what the solenoid is doing. It's powering right here. It's taking the load to the starter just from a really small input. That way you don't have to run a huge wire from your starter or your ignition switch to your starter and burn wires due to the amperage that you're trying to flow. This just takes a small wire just to tell this thing that's doing the load to go. All right, so this is my very simple starter circuit for like a small engine, or to even explain how a regular vehicle works or an older vehicle works. Because you have a starter, you have a starter solenoid, and you have an ignition switch. This is just to simplify it. Like I said, I don't have a starter out here, so I'm using the test light. So that's on my load side. I do have to ground it where the light won't do anything, but that's the same with a starter. It gets voltage put in and the housing grounds, and that's how it completes the circuit. Due to it being a 2-post and 2-pin, like I said earlier, I did have to add a ground. That goes to the ground just like the yellow one does. And then I have my starter signal. And according to the pinout that I showed you earlier, it is in the 9 o'clock position if you look at the back of the switch. And it says with battery voltage in and just starter, it should only crank. So in that position, it should only crank. So if you look at it, you will hear that go off. You will hear it click, but at least you get a visual from this. So it won't do anything until I go to the crank position. And you can hear that solenoid activate. And it's as simple as that. And this is very common. I mean, a lot of old tractors, old cars, old boats use this. I won't say that the newer, like Century cars do this, because they have some that are post whip modulated. They have a starter relay, a lot of other info that they need before they can crank. You got immobilizers and everything else. But this is how one of those circuits actually work. So I really hope this helps. I will be putting a video out that shows this on the go-kart on the small engine, so you can see it in its working order. But this is how that system operates.